Well, hey there, and welcome to another one of my cheesy YouTube videos. On this video, we are attempting to remove the blade assembly from my 6-foot bush hog mower. The blades are already off, and the reason why we're trying to take everything off is because the bearings are shot. So far, I've heated it with my rosebud torch. I've gone in through these holes which are there to access the blade bolts, and I have beat the tar out of it to try to knock it loose, and all with no avail. We will continue on and try to get this sucker off of here so that we can disassemble the gearbox and see if it's in good enough shape to rebuild, or we're going to have to replace the entire box. In the process of taking everything off, I have whacked on the bottom of the shaft a few times, and I know I've marred the threads up, but I'm not the least bit worried about that. I'll dress that up when I go back together with it. I've been using this input shaft from a Road Ranger transmission as a punch by sticking the shaft through the hole and beating on it with this sledgehammer. No luck so far. So today's a fresh day, and it's time to figure it out and hopefully get her done. I've installed a bearing splitter between the weldment for the blades and the bottom of the gearbox. I put it up here figuring I can go pick up some long 5/8 bolts, and then I got another puller that can bolt here and perhaps pull it apart. But I am going to hunker down on the bearing splitter itself and draw them to two halves together as tight as I can. And theoretically, because each half is kind of wedge shape inside here, it could, but it probably won't, but it could draw up and pop the blade assembly off. I got the bearing splitter on there and I got it drawn down tight. I've been beating on the weldment, and I've welded away on the shaft a couple times. I put that input shaft through the hole here, and I beat from up top, and she ain't budging. So the next step is more of the rosebud, and I'll get her hotter than I did yesterday and see if I can persuade it to come apart. If not, then I think the next thing I'm going to do, I'm going to take a grinder, and you can see the weld. It's only about an inch long weld on either side. I'll go ahead and cut them welds and see if this bar will fall free. If it does, I can pull the gearbox up out of the top of the machine and put this in the press and try to press it apart. Alrighty, I heated the crap out of it. I beat on it from up top through the hole. I've been beating on it down here in every direction. I hate to say, but I guess I'm going to cut these welds off right here. Got it. I ground the weld that was right here that held the two pieces together. I beat on this from up top through the hole until I started to see a crack on the weld where I ground the weld. And then I took chisels and I kept hitting with the chisel and beating on it and hitting with the chisel from both sides. Then once I got a big enough gap, I sprayed PB plaster in there, and I just kept on whacking on it till she came apart. So grinding that weld made the difference. They probably welded after they were assembled, and that very well could have put a bind on the splines. Provided I still got good parts, I'll be able to bolt everything together. Then once it's together, put the welds back in, and hopefully be smart enough to put never sees on everything. Okay, we've got the gearbox off. 6 studs that took a 15/16 socket to take them off. They're actually bolts, I guess, welded from the bottom, which I was glad to see. To my surprise, this is a straight spline. I thought for sure it was a tapered spline. Looks like there's a bearing inside that's still intact. The snap ring came out of here after I pried the seal out. Hopefully I'll be able to find a part number on it. Roller bearings on each end of this input shaft. There's a snap ring right here on the shaft that was kept the gear from walking down the shaft. So theoretically all this should drive out this way. Back of the gearbox is not opened to be able to put a punch in there, which is kind of weird. The race for the upper bearing for the output shaft is on the gear itself. I found a socket that will fit inside there like so, and I'm driving the race off the gear. The input shaft, I had to wedge chisels behind the gear and the housing and drive the chisels to push the gear down the shaft. And then once I pushed it down the shaft to where the shaft was moving back and forth inside the housing, when I got a gap between the bottom of the shaft or the back of the shaft and its bearing, I was able to wedge chisels in there and tap. Then once it got even further, then I wedged a pickle fork that was small enough that it rested on the shaft on both corners. Then I got it far enough where the input shaft front bearing came out. Able to lay the gearbox on its back and drive the gear the rest of the way out the shaft from this direction. The output shaft gear is held onto the shaft by way of these splines and that castle nut. There are shims between the input shaft gear and the first bearing, and there are shims between this race and the gear. One of the first things I did when I took the shaft out, and this is a output shaft, is I rolled it on the table. Now I got paint and stuff spilt, but I rolled it on the table to look for a wobble, and this is looking really straight. The next thing I did is I took a thread file and I laid it against it to determine what size of threads I have, and what I'm coming up with is metric 1.75. and then I took my thread file and I just worked the shaft, since I did strike it with a hammer, and I've had real good luck with thread files. I was able to run the nut down the shaft quite a ways with a pair of channel locks with little resistance. The nuts kind of beat to death from the force from the impact trying to get it loose. I could stand to run the thread file over it a little bit more, but I'm not worried about it. I'm happy that with very little bit of effort I was able to clean this up. If I had a die this size, I'd run a die on it, clean the threads up, but I don't have a metric, well, I don't have any dies this size. So anyways, this is cleaned up. Probably a little bit of PB Blaster and a wire brush on here and on here. What I'll do next. My next problem is the sealing surface for the output seal is badly pitted. I went over with emery cloth just to clean up the crud, but I mean, it's in really bad shape. Keep in mind, you can't sand a pit away without significantly reducing the diameter of the shaft. So the next trick is to use a Speedy Sleeve. Okay, the problem I'm going to have with my Speedy Sleeve is that my installation tool is not going to be able to fit up as far as I need to go. So let me see if I can find a piece of pipe or something that fit over this sleeve and contact this surface right here. If so, I'll put it over there and I'll use it to drive it on. Okay, let's talk about the Speedy Sleeve. My Speedy Sleeve was too long this way, which would be the height of the sleeve if you were to sit on a table on, you know, set the round sleeve on the table. The height, it was too long, stuck out in good ways. I took my electric grinder and I just went around the edge and shaved it. It's kind of crooked right in here. And then I took a file and I dressed it up, just rubbing on the edge. And then once I was comfortable with that, I put emery cloth on the file like so, and then I dressed it up to a smoother finish. It ain't pretty, but it's fine. The seal actually rode towards the back. This lip right here, that's part of the Speedy Sleeve. You can eliminate that. You'll see a line right here. That line is a kind of a stamp in it. So if you used to take something and hacksaw something and cut on this lip, then you can grab that lip with a pair of needle nose and just roll your needle nose and it will tear right along this seam. If I would have put a Speedy Sleeve on the input shaft, that's what I would have done. How I'd get this Speedy Sleeve off if I needed to is I'd take a ball peen and I'd use the peen side of the ball peen and I would strike it, and wherever the ball peen hits, it stretches the metal, and you just tap it around, you'll stretch the Speedy Sleeve and you'll be able to slide it right off. They also make a Loctite just for Speedy Sleeves. If I remember right, in the past I've used just regular red Loctite. I used no Loctite this time. Let's talk about installing races. I'm starting the race in here, and what I usually use, which I don't see in my shop right now, is a chisel, but a blunt one where it's been beat and it's kind of rounded, and then I kind of set it on the edge and I just keep tapping it. The blunt just helps keep it from chipping, and I'll tap on it until I hear the tone change because the metal has bottomed out. Let me just say, this gearbox is wore out. I'm able to push this race, I won't go now, all the way into place. I started tapping it, it just dropped right in. That's not good. I'm going to take a punch and I'm going to pop this cast iron in a bunch of different spots to hopefully cause some raised spots, and hopefully something that this race can grab a hold of once it gets in that far. I don't want to pop too far out because that's where the seal is going to ride, and I'll probably have to coat that seal with something just to get to sit in there good. But this whole gearbox is wore out, but we're going to try to make it work. I'm just taking the edge of this chisel, sticking it far enough in there where I know it's covering where the race is going to ride. It's the corner of the chisel. I'm popping it, and I can feel a raised spot around where the chisel dug in. I'm going to do this quite a bit. Hit it brake clean enough. Put some red Loctite in there, and then I'll tap that race into place. And also the way it's going bolt together, the race ain't going nowhere, but it's not, just bums me out that it's not a good fit. I'll clean the outside of the race. Alright, you heard it bottom out. Now after I tapped it in the first time, I was able to grab it and pull on it. It just slid right out. So it's not doing that, so maybe, just maybe, we got it. That's the cup. Here's the cone. Clean the dirt off the end of the chisel. Just gonna tap it in place. Here, bottom out. Swing it around the 180 degrees and give her a love tap there. All right, looks good. This is going to be sitting in there like so. And the seal will be riding right here. Now, the other bearing rides on the driven gear. On this gear, there'll be a nut that's going to hold all this in place. My question for the last couple days has been, do I want preload or do I want Inplay? I'm going to give it a little bit of preload. So the two are exactly the opposite from each other. Inplay is once these two bearings are in place and this is bolted up, the bearings are loose enough in their races that you get a little bit of wiggle, in and out wiggle on it. And actually you're going to get a little bit up and down because these bearings are tapered, so it'll allow it to move in both directions. But not as much up and down as it's going to be in and out. Axillary play, radial play. So have a little bit of axial play in it. That is Inplay. That's typical, especially on the older cars, where you put your wheel bearings on, you get just a little bit of rock in there. I'm going to do just the opposite, because a lot of bearings, a lot of shafts are set with preload, and preload is the bearings tight enough that they're pushing against their races, and you can over tighten it and have too much preload and it will cause premature bearing failure, just like too much Inplay will cause premature bearing failure. A lot of times what they'll do is they'll have you do you use a torque wrench to adjust your preload. You put everything together and you put the nut on that you're going to, or whatever you're going to spin it from, and then you'd use a torque wrench and you'd see how much torque it takes to turn it, and that would be the amount of preload minus the amount of torque it takes to turn the naked shaft by itself. What I'm saying is there's always going to be a little bit of torque required to roll the shaft. It may not register on torque wrench, it may be so light, but you could have a gearbox with other components tied into it that it takes a certain amount of torque just to move everything. In that case, what I would do is say I needed 5 inch-pounds of preload or 10 inch, I don't know. Those are just numbers, mean nothing. But let's say it's 5 inch-pounds. And I put my torque wrench on here with no preload on here. And I go to turn it, everything's assembled, and it takes 7 inch-pounds just to roll it. So let's say I got a torsion bar torque wrench with a little needle, and it's 7 inch-pounds as I roll it around. Well, now I need to add 5 to the 7. Now I need 12 inch-pounds to set my preload. And once it takes 12 inch-pounds, I adjust the nut, tighten it down, forcing the bearings together, and keep checking it until I got 12 inch-pounds, and I pin it and I'm done. There's also shims on here that came with it. I'm going to leave them in place after everything's tightened down. But it has to do with the spacing between this driven gear and the driving gear meeting each other properly. You don't want them too loose where the gears are, the teeth are just barely touching each other. You don't want it so tight that they're jammed into each other. So, and these gears are not perfect shape, so I'm just going to put everything back together where it was, look it over, and see if something scares the tar out of me. Let's talk bearings for a minute. This is a ball bearing, but this specific bearing should be a Conrad bearing. Conrad bearings are ball bearings that the grooves cut in the races that the balls ride in are cut deeper. So this particular ball bearing can withstand more thrust, which is a force pushed this way on the races. Well, one particular thing about Conrad bearings is that it's got fewer balls in it. Therefore, the radial forces it can tolerate are less because there's fewer balls to carry that weight. Very common, and it can withstand thrust forces and radial forces where a lot of ball bearings can't. They can only do radial forces. The bearings that I put in the output shaft are tapered roller bearings, cups and cones. They're made to withstand radial and thrust forces. and they're very typical in front wheel bearings in cars. So anyways, that's a little bit on bearings, and there are specific bearings made just for thrust, and they're flat. They'll slide onto a shaft, but they're flat, and they're made for thrust weight to be laid on them. They may be roller bearings, or they may be bushings, plain bearings, or whatever we want to call them. Just wanted to cover that. Now I went and picked up a couple snap rings to replace this broken one. And I'm going to bring something up there. What broke this snap ring is probably the fact that the telescopic drive shaft, the drive shaft's made to extend and contract as the mower goes up and down, has been quite stiff these last couple years. As the mower went up and down and the drive shaft stayed constant in its length, it would pull on the shaft, and it would push on this input shaft. And obviously it got to a point where it damaged the snap ring and popped it out of its groove. And that piece of snap ring that broke off, that busted off piece of snap ring, very well may have fallen into the upper bearing of the output shaft and destroyed it, because that's the bearing that was gone. Another thing on bearings. This is an open bearing. The balls are exposed to the gear oil. Some bearings have a metal shield snapped in here. There may be a shield only on one side and open on the other. Or it can be a sealed bearing. This bearing that I've already installed is a sealed bearing. There's a plastic seal snapped into here on both sides of this one. But the shield and the seal aren't the same thing. And open like this is very typical. And in most cases, since this gear lubricant, the oil lubricates everything, I would normally take a pick or something, jam it in that seal, and just twist it and pop that seal out of there. That goes to another thing. I don't see a check plug in the side of this box, which would be a hole that I would take the plug out and I'd fill oil from the top until it poured out that hole. And that'd give it the oil level it should be at. So I need to figure out what oil level I want this to be at. I definitely want oil level to the bottom gear to be submerged in oil, which means the bottom of the upper gear will be in that oil. And this upper gear, as it's turning, will sling oil up to the top of the gearbox. Talking very big generalities. And I learned this on a wet clutch. A wet clutch is a clutch that's designed to be lubricated with oil. There's always oil pouring on the clutch assembly. It's a regular looking, just like a dry clutch, but it's got oil running on it. And the wet clutch has usually got a scavenger pump at the bottom of the housing, which sucks oil up and recirculates it. And the reason being is you don't want your clutch housing to fill up with oil, because that clutch spinning in that oil will actually reduce the horsepower of the engine. So to a small scale, I'd say that applies here. So an overfilled gearbox could cause some issues. That's just something I wanted to keep in consideration if you're trying to figure out how much oil to put in something. Make sure there's enough to sling it and lubricate everything, but not so much that it may hamper horsepower or the performance of the gearbox. Okay, so I'm going to go ahead and reassemble this top gearbox. You got the shaft. Shaft's not pretty. The seal runs right about in here, probably right in here. Could stand to have a Speedy Sleeve, but it ain't that bad. I can move the seal a little bit, hopefully, and just make sure it's not, the lips of the seal aren't riding on a bad spot. Well, let's just pretend it's in place. Then you'll have spacers behind the gear in front of the bearing. These spacers are to help set the clearance between the driving gear and the driven gear. I'm leaving the same spacers in that were there when I tore it apart. And there's a snap ring, the one I just went and bought, sits in this groove. It keeps this gear from moving forward on the shaft. So the spacers keep the shaft from going too far this way, and the snap ring keeps the gear from moving too far this way. The bearing bottoms out in this bore, and it bottoms out on this step right here. and there's a big snap ring that goes in here just after the bearing is dropped in. So that keeps everything from going this way. Now that the input assembly is installed, all the snap rings are where they belong. The output's installed, so my gears are sitting where they're supposed to be. So I want to make sure that there is play in the gears. So I'm going to rock, twist back and forth on my input while holding my output. I can feel clunking around very little though. And it's my opinion, very little is good. I guess you could put some paste on these gears, roll it around, and then take it apart and look for the contact pattern and decide whether or not you need to shim the driven gear up or the driving gear out or whatever. It's just a simple gearbox. There's no need for that in my opinion. Here's the automobile differential. Yes, you definitely want to do that. All I got left now is put a seal on for the input. I will put a little bit of oil on the lip of this seal. And then I will put it on the shaft. I'm using a small ball peen hammer, and I'm using the ball to cut the gasket. Just wrap the gasket right on the edge. You can use a flat, the head of the opposite end of the hammer on long straightaways. There. Next, to kind of keep this properly lined up, we're going to try to peen out the bolt holes. There's a bolt hole cracked on the outside, which is not a big deal. There was no gasket on this gearbox, and the bolts had a tendency to come loose. I think I've said in other videos, I don't use much Permatex or gasket sealer. But in this case, if I can permanently adhere the gasket to this top cover, then that way if I got to pull the cover off the field, I'm not jacking around with the gasket trying to get it lined up underneath. And then once the gasket settles onto there, starts to stick real good, then I'll go ahead and take this off and cut around the fill hole. Everything's been cleaned with brake clean. Tighten these down and we'll smush it together real good so I can get the high tack to set up real good. Just want to mention, before I put the mower back in service, I'm going to take that drive shaft, telescopic drive shaft, take it completely apart, wire wheel it or whatever I got to do so they slide in and out real easy, grease it, whatever it calls for. And then the 1/2-inch bolt that holds the drive shaft on the input shaft has got to be a shear bolt. And I believe that's a grade 2 bolt. You want, if your blade was to ever contact something and want the mower to stop spinning, you want this bolt to break rather than the bust gears in the gearbox, or bust gears, even worse, in your tractor. I'm going to end this video here. You don't need to see me put it on, but thank you for watching my video. Remember, hit the like button, share my videos, subscribe to my channel, and this is the kind of stuff I do. What you see is what you get. Me and my boy Smokey here, used to be George. George has kind of got stuck up. George hasn't been coming to the shop too much because he thinks he's better than the rest of us. Remember, if you love life and learn new things, go wingless.com.